For lesson 11's homework, we're going to work more with our trig and Pythagorean identities, so our quotient one and our Pythagorean one. If cosine theta is 4 over 5, find sine and tangent. So the first thing we need to do is we need to use our Pythagorean identity, which says the sine squared plus the cosine squared is equal to 1. So we don't know sine squared yet, so we're going to hold off on that. But we do know that our cosine is 4 over 5. So we'll square that and set it equal to 1. So when we square that cosine fraction, we get 16 over 25 equals 1. We'll subtract that fraction on both sides. We get sine squared theta equals 9 over 25. Again, it's just easiest if you use your calculator. We'll square root both sides, and this one works out nicely because both of those are perfect squares, so we end up with the sine as a positive 3 over 5. Again, we're talking about side lengths, so that's why we're going to just use our positive piece. For our tangent now, our other identity was tan of theta equals sine over cosine. So tan theta equals 3 over 5 divided by 4 over 5. Some of you are probably starting to figure out that realistically what happens is our denominators of each just end up canceling out. And in here we end up with a tangent fraction of 3/4 because our 5s are going to cancel out for both of them. As we go to our next one, sine theta equals square root 5 over 5. So same thing, we're starting with sine. So therefore, we are going to use our Pythagorean identity first to get our cosine. So sine squared theta plus cosine squared theta equals 1. So we end up with the square root of 5 over 5 squared plus cosine squared equals 1. When we square that, we get 5 over 25 plus cosine squared theta equals 1. We'll subtract that fraction on both sides. We get cosine squared theta equals 20 over 25. Square root both sides, and we end up with, we got to do a little bit of work here for the 20. So that turns into square root 4 square root 5, which gives us 2 square root 5. So then we end up with a cosine of 2 square root 5 over 5. So as we go across here and we go to find our tan, all right, again, tan is sine over cosine. We end up with square root 5 over 5 over 2 square root 5 over 5. So as we keep change flip that, we end up with square root 5 over 5 times 5 over 2 square root 5. Our 5s are going to cancel, and what you should also notice is that your square root 5s also cancel. And then realistically what you end up with is you end up with a tangent equal to 1/2. Because not only did our regular 5s cancel out, but our square root of 5s canceled out. And again, you're not left with nothing on the top, you're really left with a 1 when things cancel each other out. In the third one, we have tan of theta equals 5. We want to find sine and cosine. Now this one's a little bit of a problem because even if we turn tan nicely into a fraction of 5 over 1, from both formulas, we're still going to be missing multiple values. We're going to be missing both our sine and our cosine. So when you're given a tangent, these are not really the best identities to use. And what you really should do is you should draw a triangle and fill in your values from there. So we know tan is opposite over adjacent, so we end up with 5 and 1, which means we're going to have to do straight Pythagorean theorem to find our hypotenuse. So 5 squared is 25, 1 squared is 1. We add them together, we get 26. We'll square root both sides. 26 does not split, 26 is not perfect, so our hypotenuse is just the square root of 26. So now we can figure out our sine, which is opposite over hypotenuse. We're going to rationalize here, so we'll multiply both top and bottom by the square root of 26. And we get 5 square root 26 over 26. And then for our cosine, we're going to have 1 over the square root of 26, adjacent over hypotenuse. Again, we'll rationalize here, and we end up with the square root of 26 over 26. You can put the 1 out in front, but you don't have to. So when you start with a sine or a cosine, you can use both of the identities. But when you start with a tan, it's really the best for you to just set up your picture and do Pythagorean theorem, because in both of those identities, you'll be missing multiple values, and it's going to be really hard to get started in those.